Today we are going to discuss about permutations and combinations. So now this is very easy chapter, but you have to understand properly, then it is easy. So we're starting from the beginning. So what is the permutation? So permutation means arrangement of a number of objects, of a number of objects in definite order. Okay. For example, we can say that if we say ACT, three words are there, you have to arrange this word, and how many arrangement you can make. So we can make ACT, ATC, CAT, CTA, TAC and TCA. So 6 different arrangements we can make in these letters A, C and T. That means 6 ways are there. 6 different ways are there to arrange this in order. So these important two words, arrangement and order. So we have to arrange this ACT word in definite order. Okay. Now, what is the combination? Combination means selection of a number of objects. So selection means you have to select. Suppose I am telling you have to choose class monitor, two class monitor. You have to choose two class monitor from your class. That means you have to choose two class monitor. It's not in a order. You can choose in random. Any two of them you can choose as a class monitor out of 40 students. So it's not necessary to arrange this in order. Okay. So this is the difference between permutations and combinations. Now, see that in the permutation, we are seeing 6 different ways we can arrange. Now, we are going to discuss about basic principle of counting. So how we are arranging the numbers in a different order. See that. So what is the basic principle of counting? Basic principle of counting means suppose you have m ways to do one thing and n ways to do another thing. That means you have to do m cross n ways. You have to do m cross n ways to do the both things. That means this is the multiplication principle of counting. Now, for example, suppose in your hand one black bottle, one white bottle and one red bottle. Now, also in your hand one black pencil, blue pencil and one yellow pencil. So that means you have to choose any 2 from them. So how many ways you can choose from this one? So now if you see the combination, see that if you choose from this one, that is B bottle and blue pencil, also you can choose yellow. Okay. Similarly, white bottle, blue pencil or yellow pencil. Similarly, red bottle, blue pencil or yellow pencil. So see that how many ways are there? This combination is this is 1, 2, 3, 4, 5 and 6. So six ways are there to choose. That means if the number is 3 here and the number is 2 here, that means 3 into 2, that means 6 ways are there. So this is called multiplication principle of counting. Now we are going to the next, that is addition principle of counting. See that. So now in addition principle of counting, that means if there are m ways to do one thing and n ways to do another thing, but both can't be done at same time. Okay, both can't be done at same time. This is the condition. Then we can write this is m plus n ways. Okay, this is m plus n ways. Now see that, for example, same bottles you have, so black, yellow and red, and 2 tiffin box is yours, that is green and saffron. Okay, so you have 5 things in your head, that means 3 bottles, and 2 tiffin box. Now you have to choose any one from them. You have to choose any one. That means you cannot take both at the same time. So that means you can take from one, that means 3 plus 2, that means 5 ways. Okay, that means this is the 3 plus 2, that is 5 ways. Now we are going for some problems. So now see that 2 types of problems are there. One with repetition and 2 without repetition. So what is with repetition and without repetition? So see that when we are doing with repetition, suppose 1, 2, 3, 4, 5. So 5 numbers are there in both case. 5 numbers are there. You have to take the repetition allowed, repetition not allowed. That means you have to make a 3-digit number, for both the case where repetition allowed and repetition not allowed. So now if we see in the box 1, 2, 3, 4, 5, all the numbers are given. Then if you make 5 boxes separately, now see that if we take 5 boxes, that means 5 numbers are there. Okay, now 3-digit number you have to make. Okay, 3-digit number you have to make. So now repetition allowed. Okay, that means you are putting from the unit digit. So see that if we put it here, That means you have 5 numbers in your hand. Similarly, you have 5 numbers in your hand, because with repetition in number you can put. Similarly, next also 5 numbers in your hand because of repetition. So that means we can say that the number of ways that means 5 into 5, that means 125. So 125 ways are there to, if you arrange this number with repetition. So now if we see the without repetition part, so now see that for without repetition, 5 numbers you in your hand, you are using 3. That means you can make 3 boxes. So that means without repetition, that means 5 number you can put here. So with repetition means whatever number you put here, you cannot be put in the next box. That means if you put 5, then 5 is gone. Then how many numbers are there? 4. That means you have to put here any 4 of them. So after that, 4 numbers are there in your hand. So if 4 numbers are there, if you put anything, that means 3 numbers are there in your hand. So you have to put here 3. So that means the number of ways are 5 into 4 into 3. That means 60. There are 60 different ways when without repetition. Okay. So there is a difference between with repetition and without repetition. Now, for the theory part, you can check it. For theory part, see that for theory part, without repetition, if we put R digits are there, R digits, and 1, 2, 3 up to n numbers are there. So if we put in the box 1, 2, 3, 4 and so on, the last is rth. This is 1, 2, 3, 4th, and this is rth. Okay. So this is the n. This is n minus 1, n minus 2, n minus 3, and similarly this one is n minus r minus 1. Why r minus 1? Because when we are going to the next, then minus 1 will be there. If rth, then r minus 1. So that means n minus r plus 1th. Okay. So number of odd digit numbers, we can write n into n minus 1, n minus 2, n minus 3 up to this one. So this is we are using for the factorial term. Now for the permutations, we are using NPR, where n is the number of objects and this is number of digits. So we can write n factorial by n minus r factorial. This is the word we are using, factorial. This can be used also in this case. So n minus r. Okay. This also can be used in this way. So this is n factorial by n minus r factorial. That means the number of permutations of n different objects taken r at a time. That means do not repeat, where 0 less than r less than equals to n. Okay. So if for the factorial part we are using, that means 3 factorial, that means 3 into 2 into 1 factorial. Similarly, that means 6. Okay. So the value of 1 factorial equals to 1 and the value of 0 factorial is also equals to 1. These 2 important things are there. So 1 factorial equals to 1 and 0 factorial, this also equals to 1. Note it down all of it. So, for examples, 4 factorial, number 1, 4 factorial minus 3 factorial. So 4 factorial means 4 into 3 into 2 into 1. 1 factorial means 1. 3 into 2 into 1. That means it is 24 minus 6. That means 18. So 18 is the answer. Next one, number 2. If we see that 8 factorial by 6 factorial into 2 factorial, that means 8 factorial, 8 into 7 into 6 factorial, because in the below 6 factorial is there, so 6 factorial will be cancelled. Okay, that means cancelled. So 2 into, that means 3. So that means this is multiplied. So sorry. So this is 28. This is 28. Okay. The next one, number 3. Find the value of n factorial by n minus r factorial. Okay. So that means if we write this is npr, find the value of npr where n equals to given 6 and r equals to given 2. Okay, so that means 6p2, that means 6p2 means 6 factorial by 6 minus 2, that is 4 factorial. That means 6 into 5 into 4 factorial by 4 factorial. So 4 cancel, that means this is 30. So that means 6p2 equals to 30. Note it down. So these problems are type 1 problems. These are type 1 problems. Okay. In type 2, see that objects are not distinct. So what is the meaning of that? Objects are not distinct. That means we have 1, 1, 2, 2, 2, 3, 4, 4, 4, 4. So 2 ones are there, 3 twos are there, 4 are there. So these type of numbers you have given in your hand, or words are in your hand. So you have to make the numbers and you have to make the words. So for this part, that means these are not distinct. Okay, these are not individual. One term is there. Many terms can be there. So how that will be? For example, we can say that if you create a word with MAT, that means you can see that MAT, MTA, TAM, TMA, ATM, and AMT. So 6 words you can make. That is 6 ways you have in your hand. 6 ways. Okay? 6 ways in your hand. But when you are making with MAA, 2 same word will be there. See that? 2 same word will be there. Then this number of the ways or number of the arrangement is different. See that? M, if this is first day and this is second day, whatever you can write, this is M double A. Similarly, A, M, A, and A, M. So only 3 arrangements will be there. 3 ways of arrangement will be there when we are doing with the same kind of number. So that means this is reducible. Okay, this is reducible. Now we are going to some examples to crystal clear about that part. Go for it. So now see that in word mathematics, the word mathematics is given. So you have to arrange it. So how many ways you can arrange? So see that how many M are there? How many M are there? 2 M is there. How many A are there? How many A are there? 2A. How many T? 2T. Okay. So others are not again and again. Okay, so n equals to 11. Total number is 11. So n equals to 11. So that means the number of ways equals to 11 factorial by how many times m? 2 times. How many times a? 2 times. How many times t? 2 times. Okay. So this is the way for finding this number. After calculation, to get the value, this is 4989600. Okay. Next example. The word hollow. HOLLOW. So how many words are there? 6 words. That means n equals to 6. Okay. How many L are there? 2. How many O are there? 2. So that means number of ways we can write, that is 6 factorial by 2 factorial and 2 factorial. Okay. So that means after calculation we get 180. So 180 ways are there to arrange this is hollow word. Okay. Now, see the theory part. So, in theory part, we can say that if the number of permutations of n objects, okay, where P1 one kind, P2 one kind, P3 one kind, and PK one kind, then we can say that the number of ways is n factorial by P1 factorial, P2 factorial up to Pk factorial. So this is the main formula. So number of permutations of n objects where P1 is one kind, P2 is one kind, P3 is one kind. That means P1 factorial, P2 factorial into Pk factorial. Now, another example. The next problem is that in how many ways can 4 red, 3 yellow and 2 green discs be arranged in a row if the discs of the same color are indistinguishable. Okay, indistinguishable. That means how many red are there? 4. How many yellow are there? 3. How many green are there? 2. So total is 4 plus 3 plus 2, that is 9. That is 9. So the number of ways is 9 factorial by 4 factorial, 3 factorial, 2 factorial. Okay. So that means we calculate, that is 9 into 8 into 7 into 6 into 5 into 4 factorial, right? By 4 factorial into 3 factorial means 6 and this is means 2. Okay, 6 can, 4 factorial gone, and this is 2 and this is 4. That means this is 63 into 20. That means 1260. Okay, this is the answer. Next one. So now in type 3, see that same objects wants to stays together. So that means if the numbers are given some of the numbers are, if you write together, that means suppose vowels are together, or A or I together, or vowels in the last. Okay, so this type of things when coming, then what to do? See that for a letter daughter, example 1, DAUGHTER. So what is the word? Daughter. So how many vowels are there? A, U, E. So 3 vowels are there. So conditions given, find the number of 8 letter arrangements that can be made of the letters daughter so that all vowels occur together, or number 2, all vowels do not occur together. Okay. So firstly, you have to find the all vowels occur together. That means, or if all vowels occur together, that means how many letters are there? 1, 2, 3, 4, 5, 6, 7, 8. So 8 letters are there. That means n equals to 8 here. So now see that if these are together, that means A, U and E are in one box. And similarly, the words are D, G, H, T, R. 1, 2, 3, 4, 5. Okay. That means there are 6 number of arrangements. This is 1, 2, 3, 4, 5, 6. Okay. So that means the 6 ways are there. You can arrange. So 6 factorial, the ways we can arrange. Now, this A, U, E can be changed. So what is the possible? That is 3 factorial. Now, if we multiply by the multiplication principle, then this is the answer of this value. Okay, so this is the answer of this value. That means this is number 1 part, that is the all vowels occur together. This is the number of ways, that is all vowels occur together. Calculate it by your own. Now in number 2, see that all vowels do not occur together. That means it can be any arrangement. That means only 8 factorial. Okay, but in 8 factorial, these already included. That means you have to subtract. That means 6 factorial into 3 factorial. So this is the calculation for this repetition, that is all vowels do not occur together. Okay, so this calculation is given to find the values where vowels are together and vowels are not together. Now, we're going to see another example. So very popular word, Mississippi. That means how many I's are there? So I's are there, 4 I's are there. How many P's are there? 2 P's are there. How many A's are there? That means 4 A's are there. So now in the question that is given, 4 I's not come together. So in the question you have to find 4 I's not come together. This is the question, okay? So you have to find the arrangement, that is 4 I's not come together. That means you have to find the total arrangement first, then the 4 arrangement can be subtracted. So now firstly you have to find the number of ways. So firstly you have to find the number of ways. So normal number of ways, how many words are there? So n equals to here 11. Okay, so n equals to 11. That means 11 factorial by 4 factorial for I, 4 factorial for S and 2 factorial for P. Okay, so this is the for whole word. Now calculate it. So now in number 2 you have to 4 I's. So here 4 I's are there. So 4 I's. and rest of the word. Rest of the word M 4S 2P, right? Okay, so that means 1, 2, 3, 4, 5, 6, 7, 8, 9. That means 9 are there. So that means we can write 9 factorial. That is 4 is repeated. So that means, sorry, this is 5. 4, sorry. 4 factorial by that is 8, sorry, 8 factorial by 4 factorial into 2 factorial. Okay, so now see that this is the when the eyes are together. The question is given 4 eyes not come together. That means total arrangement minus when the 4 eyes come together arrangement. That means you have to subtract the answer, that is, so number of ways, that means 11 factorial by 4 factorial, 4 factorial, 2 factorial minus 8 factorial by 4 factorial into 2 factorial. So calculate it and you get the answer. Okay. Now, next one. Now for type 4, see that when the restrictions are given, suppose in the name Rosni. So in the name Rosni, if R is fixed in the first position and I is fixed in the first position, last position, then how many permutations, number of ways you can find. So when this type of restriction are given in the question, so what to do? Now check it for this word also. So you have to start with S. For example, Rosni, this word is given. You have to start with S. That means the S is fixed here. And the left letters are given R, O, H, N, I. That means this can be changed their position, but S cannot be changed. That means how many O's are there? That means if you see that by multiple principle, that means if you put any number, that is fifth number, then this is fourth, rest of them, then 3, then 1. Okay, if we multiply, then we get the answer. That means what is this? That means 5 factorial. That means 5 factorial. So 5 factorial. So that means this is a 120. So 120 is the answer. So now in number 2, if the first one is fixed as R and the last one is fixed as I, then how many combinations are there? That means in the gap 4 boxes will be there. Any number can be jumbled here, but R and I are fixed. That means this is 4, 3, 2, 1. That means 4 factorial. So okay, that means this is 4 into 3 into 2. That means 24. 24 are there possible ways if you fix R and I in the first and last position. Now go to another example. So the word permutation. The word permutation belongs to all the vowels. Okay. See that? A, E, I, O, U. So the permutation, the word contain all the vowels together. A, E, I, O, U. Okay. So now you have to find you have to find the possible combination of this word. How many words are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 factorial is the possible combination. 12 factorial. Any two numbers are there. See that two t's are there. E1, M1, only 2. That means 12 factorial by 2 factorial is the answer for the possible combination of this word. Now, if P and S are fixed in the first and last, then how many combinations are there? That means 10 factorial by 2 factorial. Why 10? Because the first and second P and S are fixed. Only 10 numbers can be changed their position. So that is 10 by 2 factorial. So 10 factorial by 2 factorial. Now if we write the vowels are together. The vowels are together. That means A, E, I, O, U. These are together. And the rest are, see that, P, R, M, T, T, N, S. Okay. So this can be changed their position. If we take 1, 2, 3, 4, 5, 6, 7, 8. Okay. So 8, that means 8 factorial by 2 factorial into 5 factorial, because this number also can change their position. So in the box, taking one letter but can change the position. You can in the first, A in the last. So that means 8 factorial, total 8 by 2 factorial for these two are repeated, then 5 in the change of the box. Okay. So 8 factorial by 2 factorial into 5 factorial. Okay. Note it down now. So these are the permutations we already discussed. Now combinations. So combinations means you already know that the selection of the number. That means you have to selected of number. So for example, suppose the order is not important for the combination. The order is not important for the combinations. It can be first or can be last. That doesn't matter. Suppose in your hand A, B, C, 3 alphabets are there. That means if you choose this into the permutations, then what is the value? Then combinations, what is the value? So now see that for permutations you have to write A, B, C, A, C, B, B, A, C, B, C, A, C, A, B, C, B, A. But in the combination, that is only A, B, C. This order is not important. You can write anything. Okay. A, B, C. This is the thing you have to select. You have to select only one. The all possible ways is one here only. And here 6. Now go to the formula. So here N, P, R. That means N factorial by N minus R factorial. And here N, C, R. That C means combination. That means N factorial by R factorial into N minus R factorial. Okay. So now see that. How many numbers are there here? 3. How many have to choose? 3. That means C 3C3. That means the value is 1. When the N equals to R, then that means the value is 1 all time. Okay. Now here you see that this is same thing. That is N, P, R. That means you have to choose the number. You have to choose the number of 3 alphabets along. That means this gives the value of 6. Okay. So this is the difference between permutation and combination. So now we are going to the Soumya Ghoshal formula for combination. See that NCR plus NCR minus 1 equals to N plus 1 CR. This one very important formula, and we are using this one for some various purposes. Now for example, I want to show an example like that. See that is NC9 equals to NC8. Then if find NC17. Okay, so this is given NC9 equals to NC8, then find NC17. So what is the NC9? NC9 means n factorial by 9 factorial into n minus 9 factorial. Now what is the value of this? This is n factorial, 8 factorial and n minus 8 factorial. So now tell me, this is cancelled. Now 1 by, so what is the 9 factorial? That is 9 into 8 factorial, and already given this is 8 minus 9, and this is 1 by 8 factorial into 8 minus 8 into n minus 9 factorial. That means in the formula we see that when n factorial, that means n factorial, that means n minus 1, n minus 2, n minus 3 and so on, okay, up to 1. So that means it's also n minus 8 factorial means n minus 8 into n minus 9. So this part is cancelled and this part is cancelled. So we can write here by cross multiplication n minus 8 equal to 9. So n equals to 17. Okay. That means you have to find the value of 17C17, and you already told that when n and r is equal in combination, then their value is given only 1. So the answer is 1 here. Next one. In how many ways can a team of 3 boys and 3 girls? So and is given and selected, this word, selected word, that means you have to use the combination. Selected from 5 boys and 4 girls. So how many boys are there? 5 boys are there. So 5 boys, sorry, 3 boys from 5 boys. So that is 5C3, and 3 girls from 4 girls, that means 4C3. So now and is given, that means you have to multiply. So number of ways equals to 5C3 into 4C3. That means 5 factorial by 2 factorial into 3 factorial, 4 factorial, 3 factorial into 1 factorial. So if we calculate it, we get 40. Okay, so 40 is the answer. Next one. A committee of 7 has to be formed. So 7 members has to be formed. 7 members will be there. 9 boys and 4 girls are there. 9 boys and 4 girls will be there. So how many ways can this be done when the committee consists of exactly 3 girls? So number 1 condition is exactly 3 girls. Exactly 3 girls. Number 2, that is at least 3 girls. And number 3, this is at most 3 girls. At most 3. So 3 conditions is there. Now, number 1, and exactly 3 girls. That means 3 girls. And how many boys? 4. Sorry. So 3 girls and 4 boys. So that means this is 4C3 and this is 9C4. Calculate it, then we get the value. Okay, this is 504. The value is 504. Now, number 2. In number 2, see that in number 2, what is given? At least 3 girls. So at least means, that means 3 can be or can be 4. That means these combinations can be done. Otherwise, this combination can be done. Okay, so that means this is, the combination is 4C3 into, this is 9C4, and this combination is 4C4 and this combination is 9C3 plus, because the possible is, this is, both can be possible, this is plus. That means if you calculate this, we get 588 as answer. Okay, 588. 504 plus 84. Okay, next one. In number 3, see that at most 3 girls. That means no girls will be there. That means 0 girls. If 0 girls, that means 9 boys, 7, 9 out of 9 you get 7. Next, if you take 1 girls, that means 4C1 into 9C6. 6 plus 1, 7. Then 4C2 into 9C5. And last one, 4C3 into 9C4. So now, if we calculate, we get, this is 36, 336, 756 plus 504. So that means the value is 1632. Okay, so that is 1632 is the answer. So this is the different type of problems are discussed in the class. So these type of problems are normally come in the exam. So practice in home. Thank you all of you. Take care. Bye.